Hey, everybody, and welcome to week 12 of Socratic Med's MCAT supplement course. This is the supplement course for our first 15-week MCAT prep course. And today is going to be a fairly quick lecture. We're just going to talk about emotions and stress. And my name's Chris. So just again, some background on Socratic Med. We are a grassroots nonprofit that provides sensible solutions to students with disparate medical school opportunities. So basically just what that means is that we send out pretty much free MCAT prep materials. We have videos, we do office hours, just a ton of resources that are free that help those financially disadvantaged med school students, pre-med students try to become med school students. So I just listed some of our contact information below. We do have an Instagram page, YouTube page, website. Our GroupMe is the main way that we keep in touch with our students. So if you want to be added, you can use that link, or you can always email me and I'll add it to you that way. And then there's a Linktree link at the bottom as well. So that'll link you, I believe, to our YouTube page and our website again. And that'll also link you to the Calendly link where you can sign up for one-on-one office hours with myself or any of the other tutors that are here. And just on more of a personal note, my name is Chris. I'm one of the tutors here at Socratic Med. So I graduated from Stony Brook University in May of 2019. And I finished a pre-med track and I got my BS in applied math and statistics. So I took the MCAT in April of 21, and I scored a 520, which for that test was the 97th percentile. And I did get a perfect score on the psych-soc section. So my tutoring specialties are usually biology, psych, and sociology. And at Socratic Med, we do have other tutors that specialize in all areas. So we have cars, physics, and any chemistry and biochemistry as well. Okay, so we're just going to dive right in. So what are emotions? What is an emotion? Emotion is a complex state of being that consists of three different things, usually is what we say. So it's a physiological component, a behavioral component, and a cognitive component. So that physiological component, it involves our body. So the physical arousal of our body. So like, for example, when you watch a scary movie, the physiological response to fear is going to be sweating, increased heart rate, really anything, your body's response to that epinephrine that pops up with that fight or flight response. All of those changes are going to constitute that physiological component of emotion. We have a behavioral component as well. So that's a behavioral or physical response to the stimulus causing the emotion. So in the same example, you may scream or look away very quickly during a scary scene. So the behavioral aspect of emotion is basically how we're reacting to the stimulus. So just like the example said, the behavior would be that sort of scream or that look away from an aversive stimulus. In this case, it would be if you're watching a scary movie. And then we have three, cognitive. So the interpretation of the situation. You may quickly experience fear during a jump scare in the movie, but quickly realize the monster has a laughable costume on, for example. So cognition does go into emotion. We sometimes have these sort of primary, these really knee-jerk reaction, knee-jerk emotions to a situation, but after cognitive appraisal and we realize what the situation is really about, our emotional state may change. For example, that last example that we just said about a monster popping out, the idea of a jump scare is pretty scary, and in practice it is scary, but as soon as we realize as soon as that moment passes, the jump scare isn't really there anymore. We realize what is popping out at us. We quickly come back to the realization that we're watching a movie. In the aftermath, that quick fear emotion is going to just fade away. And we may laugh a little bit. We may feel a little bit foolish that we were so scared by it. So there's definitely a cognitive component that's involved in emotional processing as well. So universal and adaptive emotion. So according to Charles Darwin, emotions had a biological basis that should transcend cultural differences. So obviously Darwin, you know him from natural selection. When we study evolution, we talk about Charles Darwin. So he was a proponent for this idea that our facial expressions had this sort of universal norm, that there were certain facial expressions that had a biological basis that across all cultures, everybody would be able to recognize. And it's still to this day, it seems that is true. So we recognize 6 universal emotions currently: happiness, sadness, surprise, fear, disgust, and anger. So if you look to the right, you can see this diagram right over here that shows all 6 of these. And you can show this to a person in Florida. You can show this to a person in northern China, and they should both, in theory, be able to decipher what each of these faces means. That's why we call them universal. So these emotions are all recognized and used across cultures, but keep in mind expression of these emotions may vary. So every one of these cultures across the world should be able to recognize it, but that doesn't necessarily mean that they're all going to use all of these emotions equally. So there are some cultures that might frown on fear, on expressing fear. So, in those cultures, you're going to see a lot less, emotional expression that would invoke the emotion of fear. So emotional arousal we have is also related to performance. So the Yerkes-Dodson law shows that the performance increases as emotional arousal does, according to an inverted U curve. So with an optimal performance occurring at moderate arousal, I actually have, I think I have a diagram of the Yerkes-Dodson law. We're going to come back to that a little bit when we talk about stress as well. But the inverted U curve is just an upside down U. And basically just what that means, it's sort of like, what it means is that at moderate stimulation, at that moderate emotional arousal, that is where optimal performance occurs. And we're going to talk about that a little bit in a little bit again, because that also relates to stress and stressors that we'll talk about. So just keep in mind that moderate, according to the Yerkes-Dodson law, sort of that moderate activation, moderate emotional arousal, moderate stress arousal usually leads to the optimal performance. We don't want to get on either side of the curve too far. And then we have emotions also provide a means of nonverbal communication and empathy. So we communicate through emotions, and we also experience empathy through emotions. So we can feel other people's emotions with them, and that's one of the things that makes us uniquely human. And that is again one of the adaptive components of emotion. It provides this sense of social cohesion, this advanced sense of communication, and it really allows us to form, a cohesive social unit, be that a family or a society or whatever level you want to analyze. And we have some theories of emotion. So we're going to go over the three major theories, the James-Lange Theory, the Cannon-Barr Theory, and the Schachter-Singer Theory. Okay, so the first one is the James-Lange Theory. So this theory came about just at the end of the 19th century. So James-Lange theory suggests that an emotion is the result of an immediate physiological response to a stimulus and not the other way around. So at the time, the common sense way of thinking was that we would have this subjective experience of fear when we were confronted with an aversive stimulus. And upon understanding that we're experiencing fear, our body would then mount this autonomic response and would continue with that sympathetic response. However, the James-Lange theory kind of challenged that, and it basically said it's the other way around. So it basically said that your body responds automatically to whatever that stimulus is, and then because you are able to identify what is happening with your body, that creates the subjective experience of the emotion. So for fear. So if we look down at the diagram at the bottom, is basically what I was just saying. So that first common sense theory, we have the stimulus, the person is going to react with fear, and then the body is going to respond, arousal. So that would be increased heartbeat, increased blood pressure, vasodilation, giving off heat. So that was the common sense theory. But then the James-Lange theory said that the first thing that happens chronologically when you are exposed to an aversive stimulus, like say a growling wolf, you're going to have a bodily response first. That physiological response is going to occur first, and then it is our recognition of our own body, internally of our own body. It's our recognition of that specific state of arousal that creates the experience of fear. So evidence that supports this theory, altering breathing patterns can lead to changes in emotional state. So we're, altering our autonomic response, and then that should in turn alter our subjective emotional experience, which it does seem like that happens. So that's something to keep in mind. And we also have those with spine damage who are unable to respond to stimuli with physiological arousal will also experience reduced emotion. So these are people who their nervous system has sort of been severed at a specific point that reduces their ability to experience physiological arousal. So their sympathetic response is not going to be as strong as someone who didn't have spine damage. And in these cases, we actually see that these people do experience reduced emotions. So that's another, pretty important point of supporting evidence for this theory. We have criticisms of the theory as well, though. Some emotions share the same physiological state. So fear and sexual arousal, for example, if you're not looking at the two of those emotions subjectively, and we were just, taking the vitals and just looking at the physiological response of an individual that's in a state of fear and an individual that's in a state of sexual arousal, we would get extremely, extremely similar numbers. So according to the James-Lange theory, there's really an assumption that one sort of physiological state should correspond to one emotion, because our deciphering of that emotion is dependent on how we see our own physiological state. So we're not really looking at the situation, we're just looking, the only factor, according to the James-Lange theory, that produces the emotion is our response to our own physiological arousal. So in that case, it sort of poses a problem that we have similar physiological states that pair up to different emotions. And then also the theory assumes that we're able to label these physical states accurately. So not only should there be one-on-one with these physiological states, but we have to be able to identify and label these physiological states very quickly. So there's not necessarily a lot of evidence that says that's exactly what's going on. So after the James-Lange theory, Walter Cannon and grad student Philip Bard came up with this theory in response to that theory. So the Cannon-Bard theory basically claims that physiological response and emotional response occur simultaneously and independently. So there is no cause and effect relationship between the two. So if we go down and we look, the stimulus over here is going to be a snarling dog. First response, we're going to look, see that snarling dog, subcortical brain activity, we're going to realize the situation. And then the second response, at the same time and independently, we are going to have that autonomic response and that subjective conscious fear. So this theory is able to explain the overlap in physiological state between emotions like fear and sexual arousal, because we no longer have to have that sort of one-on-one relationship between physiological states and subjective fear and those different types, those different types of emotions. So it also struggles, however, to explain why the emotional state can change by changing physiological state. So like we were talking about before, changing those breathing patterns, according to the James-Lange theory, if we change our breathing patterns, that would change the autonomic response, which would change the emotional state. So that makes sense. But if we're looking at that same phenomenon through a lens of the Cannon-Bard theory, if we change our breathing, we could supposedly change the autonomic nervous system functioning, but that, according to the Cannon-Bard theory, is completely independent from our actual emotional processing. So our state of arousal, regardless if it's high or low, should have no bearing on the actual emotional state. So it doesn't really do a good job to explain why, using breathing techniques can either heighten or lower our physiological state of arousal. And then the third theory that you should definitely be able to know and identify for the MCAT is called the Schachter-Singer Theory. So according to this theory, we experience a physiological arousal first in response to a stimulus. So that's very similar to the James-Lange theory. However, it is then our cognitive appraisal of the situation that leads to an emotional response. So now we're talking about cognitive appraisal of our external environment. So similar to the James-Lange theory, but in the Schachter-Singer theory, it is situational appraisal rather than immediate one-to-one correlation that results in this emotional response. So remember, when we're talking about the James-Lange theory, it's the same as this one, where we're first going to experience that physiological arousal. But according to the James-Lange theory, what happens after that is it's pretty immediate. We recognize what our body is doing, and then just from that recognition alone, we have our emotion state. The Schachter-Singer theory is a little bit more comprehensive and sort of explains situational context. So it's the same thing. We see a snarling dog. We get that physiological arousal. The only thing that's different, though, is in order to interpret that physiological arousal, we use the sort of situational context of what's actually going on. So we're not just looking at our own physiological state, we're looking at the actual situation that we're in. So we will look over, see that there's a dog that is snarling his teeth and growling, and we would know from past experiences that we are in trouble. And that cognitive appraisal would produce that conscious feeling of fear. So with the Schachter-Singer theory, it's got a similar timeline as the James-Lange theory. We're just taking into consideration cognitive appraisal of our outside environment. So this theory accurately explains the similar physiological state, but different emotion problem. What we were talking about before, how the James-Lange theory needs that sort of one-to-one with physiological state and emotions. This solves that problem because we have that cognitive appraisal. So we could have a similar physiological state, say our last example, fear and sexual arousal, but because in the Schachter-Singer theory, it accounts for that cognitive appraisal, we would be able to consciously decipher if we are in a situation that calls for fear or a situation that calls for sexual arousal. So it definitely explains that much better than the James-Lange theory. And like the Cannon-Bard theory, though, this theory does not explain the effect of changing behavior to alter the cognitive aspects of emotion. So all of these theories really do have their setbacks, and they have points that support them. So like a lot of theories that we study in the soft sciences, it's just really a good idea to know all of the theories, because the fact of the matter is the truth is usually some sort of blending of multiple of the leading theories. We can get useful information from all of these theories, from different pieces of each of these. Quickly, the role of neuroscience. So emotional circuits in the brain have eluded neuroscientists for years. We're still, looking at the brain, trying to connect neuroscience to actual consciousness. So once thought emotional center model of mapping specific emotions to specific brain areas proved to be too simplistic, and emotions work more as circuits throughout the brain with similar emotions sharing similar patterns. So that's just one example of, how we have to sort of restructure the way we look at neuroscience when we're trying to figure out these things that have psychological consequences. So at one point, we may have thought that there was a specific emotional center in the brain or specific parts of the brain that are responsible for specific emotions. But with technology, imaging technology, better methodology for when we conduct clinical research, we start to realize the picture is a little bit different. So if you look at this diagram, we see these two almost looks like 3D, like MRIs. So we have contentment and anger, and that's basically showing the parts of the brain that light up when the patient is subjectively reporting these experiences. And they will light up in those same exact spots when the person is experiencing a similar emotional state. So it's more of an emotional circuit throughout the entire brain than having these little emotional centers specifically in the brain for specific parts for specific emotions. And similar emotions, although they're slightly different, will probably use similar, although slightly different circuits in the brain. So there's a lot that we don't know about, and there's not too much that's going to be on the MCAT about the role of neuroscience in emotion, but it's definitely important to know. Because we have the limbic system as well, which will more so be on the MCAT. It'll be a lot higher yield than the previous slide. So the limbic system is just a collection of structures in the brain that is involved in the behavioral and emotional response. We do have some lectures on the brain. They might not be in this 15-week supplement, but they might be in the original 15-week MCAT course. So if you need to brush up, I definitely recommend going back. So the amygdala is an almond-shaped structure located deep in the brain that controls much of the emotional response, and it can communicate directly with the hypothalamus. So the amygdala, it's most famously implicated in aggression and fear processing, but it also does play a larger role in other emotional processing as well. So the hypothalamus can control the body's physiological response, the sympathetic response to danger, say. So the hypothalamus has control of that HPA axis as well. And it has control, it's able to, make the body release these chemicals, these hormones that are important for the sympathetic response, like epinephrine, norepinephrine, and cortisol, say. So the amygdala can also send information to the prefrontal cortex where decisions, behavioral responses to the stimulus can be generated. So the prefrontal cortex, as you should know, is towards the front of your brain. It's in the cerebrum. Specifically, it's the frontal lobe. And that's the part of your brain that is important for decision-making, judgment, and planning. So the amygdala also coordinates with the prefrontal cortex because a lot of times if there are those sort of primal emotions, like you're confronted with fear or something like that, you really have to make quick decisions. So where better to send this information than the decision-making center of the brain? All right, so this brings us to our first review question. Read this over. Once you're done, I would take about a minute and a half, maybe 2 minutes, just because there are a lot of words. But pause the video right now. When you unpause it, we'll go over it. Okay, so which of the following answers does not accurately match the specific theory of emotion with its correct order of events? So if you got C, you are correct, and we will go over it. So according to the Schachter-Singer theory, a boy who is confronted with a growling dog will experience an autonomic physiological response and emotional response that are independent of each other. So that is not correct. The Schachter-Singer theory does not say that the emotional and physiological response are independent. That is the Cannon-Bard theory. So just because the wrong theory was listed in A, it's incorrect. So B, according to the James-Lange theory, a boy who is confronted with a growling dog will experience an autonomic physiological response, followed by an evaluation of the current situation as a dangerous one that should evoke fear, resulting finally in the emotional response. So we're sort of in the right order, but again, what you have to watch out for is that we're talking about the James-Lange theory, so there should be absolutely no cognitive appraisal of the situation. The James-Lange theory, what the autonomic response is directly responsible for the emotional state. There's no cognitive appraisal. There is no consideration of the outward situation at all. So B is incorrect. D, according to the Cannon-Bard theory, a boy who is confronted with a growling dog will experience an autonomic physiological response followed only by immediate labeling of this arousal, resulting finally in the emotional response. So that's actually describing the James-Lange theory. It's in the right order, and only the immediate labeling of the arousal results in the emotional response. So that's the James-Lange theory, not the Cannon-Bard theory. So that's why that's incorrect. And then we have C, the correct answer. So according to the Schachter-Singer theory, we have blah, 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 followed by an evaluation of the current situation as a dangerous one that should evoke fear, resulting finally in the emotional response. So in C, we finally have the correct name of the theory matching the correct order of events that should unfold according to it. Okay, so we're going to talk a little bit about stress. What is it? Why we have to manage it, and just some ways of managing it. So the nature of stress. Stress is experienced as a set of psychological and physiological symptoms. We often just think of them as psychological, but there are often physiological responses to stress as well. Although necessary for survival, prolonged periods of stress can be detrimental to health and lead to conditions like immunosuppression, infertility, and hypertension. And that's mostly for hormonal reasons. Mental reasons as well, but for example, cortisol sort of affects your immune system. It inhibits white blood cell production, so it actually does cause immunosuppression. So stress truly is detrimental to your physical health. So not everybody responds to the same stressor in the same way. Therefore, appraisal plays a huge role in how we experience stress individually. So for example, the MCAT may be a stressor to someone, and it most likely is. But it's your appraisal of the situation that can turn an extremely stressful hurdle into a moderately stressful challenge. So it depends on how you look at it. If you're looking at it as this mythical beast that you're never going to be able to accomplish, and you don't have confidence in yourself, and you're letting yourself get stressed out over this test, it's not going to be fun, and it's just going to stress you out, and you're much more susceptible to overwhelming yourself. However, if you look at it as a challenge, something that you are good at solving, and you know that if you put in the hard work, you're going to get what you want, it could be a motivating factor, and it could be, moderate stress can motivate you to overcome this challenge and sometimes even do better than what you expected. So stressors are categorized into 3 groups based on their severity. So at the least severe end of the spectrum, we have daily hassles. So these are the least debilitating. These are just the things that'll kind of annoy you from day to day, stress you out. So these are issues like traffic, if you have to pay bills, if you lose your car keys, say, and you're late to work, just things like that. That really just mess up your day and stress you out. So some can deal with these stressors very efficiently, and some people will get overwhelmed very quickly with them. And it really, I think it just depends on what sort of life you're living, and how, how adjusted you are to change. So significant life changes include moving, getting a new job, death of a loved one, changes in romantic relationship status, having children. So it's basically just it's pretty self-explanatory. It's basically just any sort of life change, any sort of large change in your life. So regardless of if it's a good or a bad change, it's stressful because humans are creatures of habit. So when we disrupt our habits and we disrupt our schedules, it's a little bit stressful. We need time to adjust to it. And again, it's just your outlook and other factors that will affect just how stressed out you get by it. So several concurrent events can increase one's risk of disease and death. So we're getting a little bit more dangerous, it's getting a little bit more stressful. Young adulthood, for example, is considered an extremely stressful time just because of the frequency of how significantly and how quickly your life is changing. So you're probably going to cycle through romantic partners. You'll probably move around a little bit. You'll spend a lot of money in school. You'll probably, move out, move in, make new friends. So there's a lot of change going on, especially in your 20s. And if you don't take care of yourself and you're not careful about it, it does increase your risk for disease and death. And then three, the worst type of stressor we have are catastrophes. These are large-scale events like natural disasters, war, mostly just unpredictable natural events that pretty much upheave your life and change them around. So physical and mental health consequences can be evident for months to years after catastrophes. And another example is many people developed anxiety, depression, PTSD after the 9/11 terrorist attack in New York. So these sort of catastrophes that really just uproot people's lives. For example, the whole Russia-Ukraine situation that's happening right now. There are millions of Ukrainians who are being displaced because of the war, having to leave their homes. So that would definitely count as a catastrophe. Catastrophes, of course, they are significant life changes, but they're so much bigger than that, and they're so much more destructive that we have to label them as a completely separate type of stressor. A little more on stress. There's that Yerkes-Dodson bell curve that I was talking about a little while ago. So a moderate amount of stress can actually improve psychological functioning by providing energy and motivation to accomplish a goal. Too much stress can impair psychological functioning by causing fatigue and inability to concentrate. So we see right over here, this graph, this sort of parabolic curve. To the left, we have increasing attention and interest as our arousal increases. So somewhere in the middle of this sort of subjective scale, we have optimal arousal and optimal performance. But then as we continue to increase our arousal, you see our performance starts to decrease again. And that is impaired performance because of strong anxiety. So that's sort of arousal and stress. If we have too much of it, it becomes anxiety and it starts to affect our performance negatively. So when we are overstressed and perceive we are no longer in control of the situation, we may develop something called learned helplessness. And that's basically just defeat and exhaustion due to our perceived inability to affect the situation. So if you time after time are stuck in an awful situation and you realize that you think that there is nothing you can do to get out of it, you're going to stop trying. And that's called learned helplessness. So our response to stressors. When we encounter a stressor, our sympathetic nervous system mounts the fight or flight response, mainly by promoting the release of epinephrine and norepinephrine into the blood. The HPA axis, remember the hypothalamic pituitary adrenal axis, in response to stress can also release CRH, which is corticotropin releasing hormone, and that stimulates the adrenal glands to release cortisol. Cortisol is colloquially known as the stress hormone or the anti-stress hormone, and it is released in the body. High cortisol levels are associated with stressful environments in humans. So cortisol allows the body to use fat more efficiently as an energy source, so blood sugar levels can remain constant. Cortisol is usually released as a part of the sympathetic response. So there would be need to keep your blood sugar levels high during a period that you need to use all of your energy stores. You don't want that blood sugar to dip low, specifically because glucose is the preferred form of fuel for your brain. So you need to make sure that your blood sugar levels can adequately supply your brain with energy. And that's what cortisol helps us to do. It's sort of harmful, though, in the long term if cortisol levels are too high. So long-term stress and increased cortisol levels can lead to immunosuppression due to its inhibitory effect on white blood cells. It can also lead to more fat deposits. And it's just overall unhealthy to have elevated cortisol levels for long periods of time. So emotional stress like anger can also trigger cardiac events. So it's not just stressors from the environment, it's also internal and emotional stress. So like stress like anger can trigger cardiac events, and anxiety, for example, can trigger panic attacks. So we can have these physical responses from emotional causes. and how we manage stress. So since there's a level of stress that is optimal for motivation, according to the Yerkes-Dodson law that we saw a couple of slides ago, it is better to manage our stress rather than try to eliminate it. So it's pretty impossible to eliminate it, and we wouldn't want to if we could. So many people vary in their abilities to control their stress. And as you get older, you start to develop different techniques to control your stress. As you learn, yourself and your mind, you get better at it. And one way of coping shown to be effective is aerobic exercise. So this is a super popular one. Exercise has been shown to lower blood pressure. It may help increase the production of norepinephrine, serotonin, and endorphins. So aerobic exercise, it does produce that sense of euphoria. And a lot of people say that it actually does help long-term to manage stress. So another resource for managing stress is social support, and stronger social support has been associated with lower blood pressure, lower levels of stress hormone, and stronger immune functioning. So definitely be aware of that fact as well. Social support is actually a very good indicator specifically of cardiac health. I know people with fewer social networks actually, I believe, have a higher event rate when it comes to cardiac health. And I think it's disease in general as well. Social support is super, super important to humans, especially just because we're so affected by stress. And it is one of the main ways that we can manage and alleviate stress. Okay, so review time. Read this over, take about 1.5 minutes, 2 minutes, and then we will review. So which of the following would be most accurately labeled a significant life change? We have Roman numerals 1 through 4, and the correct answer is D, 2 and 4. So Roman numeral 1 is finding a parking ticket on your car windshield. 2 is getting a new roommate. 3 is being displaced from an earthquake. And 4 is going back to school for a degree. So a significant life change. If we look at 1, finding a parking ticket on your car windshield, most likely that is not going to be a significant life change unless that is the last parking ticket and you have not paid 50 of them and you get arrested on the spot, then it may be a significant life change. But chances are, if you find a parking ticket, you're just going to be pretty pissed and you're going to want to pay it off as soon as possible. So that would be more of a daily life hassle. That's not really significant life change. Getting a new roommate, however, I would consider a significant life change because you're changing your schedule, you're changing your daily routine, and you're welcoming a new person into your life. So getting a new roommate is a life change. Being displaced from an earthquake is a life change, but it would definitely be more accurately described as a catastrophe because that is sort of a life-shattering event that is a natural disaster, and it was just not predictable. So being displaced from an earthquake is going to be a little bit more severe than the other significant life-changing events on this list. So it would more accurately be labeled as a catastrophe and would not be a significant life change. Going back to school for a degree, I would label as a significant life change because, again, you're changing your routine. You're going back to school to earn a new degree and possibly even start a new career path. So 4 would also be a significant life change, which means 2 and 4 are correct. So D would be the correct answer. And that is all I have for tonight. That is my email, christopherscagnelli1@gmail.com. If you have any questions about the lecture, any questions, any comments, you wanted to correct me about something, you want to be added to the group me, or if you have any other questions about Socratic Med in general, please feel free to shoot me an email and I will try to get back to you as soon as possible. Other than that, have a great night and happy studying.